Hello and welcome to the second lecture on computer networking. In this lecture I will explain about the OSI reference model. So now let's start. International Standard Organization ISO is established in 1947 and it is a multinational body dedicated to worldwide agreement on international standard. It is an international organization and it deals with different standard which is concerned with the people worldwide. An ISO standard that cover all aspects of the network communication. Now that standard which cover network communication is the open system interconnect. That is called open system interconnect, OSI model. It was first introduced in the late 1970. In 1984, the open system interconnection OSI reference model was approved as an international standard for communication architecture. And in 1984, the Open System Interconnection OSI Reference Model was approved as an international standard for communication architecture. Let me clear you that before, when the network started, every vendor has their own protocol or they have their own rules to operate these networks. But when these networks are started to communicate with each other, different networks are communicating with each other, so it create problem because they were on the different protocol or different set of rules. So all over the world they feel that we need an international standard which cover all the networking standards. So that was the reason that OSI reference model was developed. OSI reference model has 7 layers. So the question is why we have layered approach. What is the advantage of layered approach? The process of breaking up the function or task of networking into layer reduce complexity. First of all, its advantage is it is reduce complexity. For example, if you have a problem, first of all you check the wire or cable. So you are dealing with the physical layer because it has a physical layer. I will explain about later this in detail. Each layer provides a service to the layer above it in the protocol specification. It just provides services to the layer above it. Each layer communicates with the same layer software or hardware on the computer. The lowest layer, for example, transport, network, data link and physical, fourth, third, second and first are concerned with the flow of data from end to end through the network. While the upper layer of the OSI model, for example, application, presentation and session, which is layer 7, 6 and 5th, are oriented more toward services to the application. Now this is the diagrammatic representation of OSI reference model. It is very important if you are working in networking industry. You must know this layer approach, OSI reference model. So the first layer is physical, second is data link layer, third is network layer, fourth is transport layer, fifth is session layer, sixth is presentation layer and the last one is application layer. Now let's discuss them one by one. Physical layer. It is the first and lowest layer of the OSI reference model. It is the first and lowest layer of the OSI reference model. The physical layer consists of the basic networking hardware transmission technology of a network. It consists of basic networking hardware transmission technology. By it we mean cables. It is a fundamental layer underlying the logical data structure of the higher level function in a network. The physical layer defines the means of transmitting raw bits rather than logical data. It dealing with raw bits. For example, raw bits mean zeros and ones. The bit stream may be grouped into code words or symbol and converted to a physical signal that is transmitted over a hardware transmission medium. For example, this bit stream, for example 0 and 1, it can be combined into code, different code, depending on the signal types, and it's passed to hardware transmission medium. For example, hardware transmission medium means wire, physical layer. The physical layer provides an electrical, mechanical and procedural interface to the transmission medium. The shape and properties of the electrical connector, the frequency to be broadcast on, the modulation scheme to be used in similar low-level parameters are specified here. For example, what is the shape and properties of the electrical connector? What kind of shape we have? what is the property of the electrical connector, what type of connector we have, the frequency to be broadcasted on which frequency it should be broadcasted, the modulation scheme, which modulation scheme it is using. Modulation means to modulate and demodulate, and similar low level parameters are specified here. Low level parameters are specified here at the physical layer. Function of the physical layer. Representation of bits. Data in this layer consists of stream of bits. Stream of bits means zeros and one. Data is here in the form of 0 and 1. The bit must be encoded into signal for transmission. First of all, it must be encoded into signal. The signal is transmitted. The bit is first encoded into signal, and the signal is transmitted. It defines the type of encoding. For example, how zeros and ones are changed to signal. The physical layer defines that how these raw bit, for example 0 and 1, is encoded into signal, and this signal is transmitted. Second function of the physical layer is synchronization. It deals with the synchronization of the transmitter and receiver. The sender and receiver are synchronized at bit level. So first of all, the sender and receiver are synchronized at this level. Data rate. Other function of physical layer is data rate. This layer defines the rate of transmission, which is the number of bit per second. How it will be transferred. For example, 10 megabit per second, 10 megabit per second, 15 megabit per second. It is defined here. Data rate. Interface. The physical layer defines the transmission interface between devices and transmission medium. It defines the interface between these devices. Line configuration. This layer connects devices with the medium. Point-to-point configuration and multi-point configuration. Topology. Topology is the schematic representation of the nodes. So at physical layer, devices must be connected using the following topology. For example, it should be mesh, star, ring, and bus. These are determined by physical layer. Transmission mode. Physical layer defines the direction of transmission between two devices. It also defines the transmission mode. For example, between the devices, it should be simplex, half duplex, or full duplex. In simplex, communication is taking place in one way. In half duplex, communication is taking place two ways, but one way at a time. In full duplex, communication is taking place in both directions at the same time. It deals with baseband and broadband transmission. Now the following network equipment provide physical layer services. These were the functionality. Now let's discuss the equipment which is working on physical layer. So there are 3-4 devices working, which is as follows: network interface card, NIC, network interface card, network hub, modem, repeater. Let's discuss some of them. Network interface card. A network interface card provides the computer with a dedicated full-time connection to a network. For example, if a device has to communicate in a network, it must have an NIC, network interface card. Personal computer and workstation on a local area network LAN typically contain a network interface card specifically designed for the LAN transmission technology. Second device which operate on the physical layer is network hub. A hub is a common connection point for devices in a network. Hubs are commonly used to connect segment of a LAN. It connects segment of a LAN or different node of a LAN. A hub contains multiple ports. A hub may contain multiple ports, 4 or 8 depending on the hub type. When a packet arrives at one port, it is copied to the other port so that all segments of the LAN can see all the packet. So it through broadcast, which increase network burden. So it is a disadvantage of the network hub because it is a dumb device. It is not an intelligent device like switch. Modem. A modem modulates outgoing digital signal from a computer or other digital device to analog signal. For example, when our communication is taking place, for example, we have one device here. If it's go to this device, first of all, the digital signal, it must be converted into analog to be transmitted from this wire. or wirelessly. Then at this point it must again be converted into digital form. So this process is called modulation. A modem modulates outgoing digital signal from a computer or other digital device to analog signal for a conventional copper twisted pair telephone line, and demodulate the incoming analog signal and convert it to a digital signal for digital device. Because this device is digital, it can understand only digital, but this here it is analog. So from here to here we need a modem, modulation and demodulation device. Next we go to the second layer of the OSI reference model, which we call data link layer of the OSI model. So the main function is it's allow a device to access the network to send and receive message. In physical layer we have got bit stream 0 and 1. Here we have got messages. Offer a physical address to a device that can be sent on the network. It provides physical address. Work with the device networking software when sending and receiving messages. Provide error detection capability. Data link layer provide error detection capability as well. It is responsible for node-to-node delivery of data. It receives the data from network layer and create frame. First of all, it receives data from the network layer. Network layer is the third layer of the OSI reference model. It creates frames, add physical address to these frames and pass them to physical layer. For example, it receives some data, its frame, and it's give one address, physical address to these. It put one header, and these frames are passed into physical layer again. Data link layer consists of two layers. Now it has got two main sub layer of the data link layer. Medium access control, which we call MAC. Establish and maintain link between communicating devices. What is the role of the MAC? It establish and maintain link between communicating devices. For example, if there is two devices, it establishes links between these devices. Logical link layer, LLC. Define the method and provide addressing information for communication between network devices. Now it defines how this communication will take place. It's the functionality of the logical link layer. Function of data link layer, physical addressing. After creating frame, first of all we create frame. Digital data link layer add physical address of sender, receiver, MAC address in the header of each frame. Now this is frame, for example, it adds one header which we call MAC address in the header of each frame, and it's sent to sender and receiver. After creating frame, data link layer add physical address of sender, receiver, MAC address in the header of each frame. In this header we have information of the sender and receiver of MAC address. Second function of data link layer is framing. Data link layer divide the bit received from network layer into frame. First of all, it convert into, or it divide into frame. Frame contain all the addressing information necessary to travel from sender to receiver. It has got the information that where it has to travel from source to destination. Flow control. Data link layer prevent the fast sending from drawing the slower receiver. For example, if communication is taking place between sender and receiver and it's transmitting fast, but the receiving device is slow, so it controls the flow of data. Data link layer prevent this to happen. Other function is access control. When single communication channel is shared by multiple devices, MAC layer of data link layer provide help to determine which device has control over the channel. For example, which device has to control the channel, which device has to send the signal, and in which format. So it is the function of access control. Error control. It provides the mechanism of error control in which it detects and retransmits damaged or lost frame. For example, if there is lost or damaged frame, it helps to provide retransmission of that frame. Common networking components that function at layer 2 include, for example, we have some networking device which operate at layer 2. Data link layer is the following: network interface card (NIC), Ethernet and token ring switches. Third is bridges. Let's discuss some of them. Bridge. A bridge is a hardware device also used to connect two lane segments to extend a lane. For example, if we have very big network, now to reduce the broadcast, we divide it into two parts. So for example, here is one network, here is another network, and these are connected through these bridges. This is a bridge. So it's reduce the broadcast. For example, this, if it's the data is in this side of the network, it's sent to this one, and if it is on this side, it's sent to this one, but it's unnecessarily the broadcast is reduced. A bridge is a hardware device also used to connect two lane. For example, two lane, it can also connect two lane segment to extend a lane. Unlike a repeater, a bridge uses two NIC to connect two segments. It listens to all traffic and recognize frame format. It also forward only correct complete frame and discard the collided and error frame. It just forward the complete frames and discard the frame which is collided error frame. If there is error or collided, it discard the frame. It just only forward the complete frames. It's the function of the bridge. Switch. A network switch is a computer networking device that connects devices together on a computer network by using packet switching to receive, process and forward data to the destination device. It works on layer 2, data link layer. Unlike least advanced network hub, a network switch forward data only to one multiple device that need to receive it. That is the intelligence of the switch. That's why it's reduced the broadcast, unlike hub. Rather than broadcasting the same data out of each of its ports, in this it reduces the broadcast in the network. That is why switch is an intelligent device and hub is a dumb device. So whenever it's possible, use switch instead of hub. This is the diagrammatic representation of switch. It is a Cisco switch. Next we go to network layer, which is the third layer of the OSI reference model. Network layer is the third layer of the OSI reference model. Main task of the network layer is packet delivery from the source to the destination. Here is what we have got. We have got packet. In the physical layer, we have got 0 and 1. We have got bit. In data link layer, we have got frame. But here at the network layer, what we have got? Packet. The network layer typically provides information about which transport layer protocol is being used, as well as local checksum to ensure data integrity. It provides to ensure that data integrity is maintained. Host addressing. Every host in the network must have a unique address that determines where the host is. This is just like our address in the town. On the internet, address are known as the internet protocol address. For example, if we have a network, we first of all we must know that what is the network address and the host address. For example, this is determined by network layer. This is just like the addressing in our town. For example, we have first of all town address, then we have street address, then we have the house address. So street address is like network address and house address is like host address. Connection model. The network layer uses connectionless communication. For example, IP is connectionless. Message forwarding. Since many networks are partitioned into sub-network and connect to other network for wide area communication, network uses specialized host called gateways or router to forward packet between network. Now if we have heterogeneous network or different network which are connected with each other, we must have a router or gateway to be reached to these heterogeneous network. For example, layer 3 network layer, coming to down to layer 2, and again to physical layer. That issue at the network layer. What issue we have to face at the network layer? First of all, there is the problem of routing. How to forward packet. Second is how to calculate a path from source to destination. For example, here we have one node, here we have another node. How we can calculate the path from source to destination? This is the second issue. First of all, it determines that how to forward packet from source to destination. Next, it's determined how to calculate the path, in which path it should go from source to destination. Either it goes through this way, or it goes through this way, and then this way. So it's the main issue at the network layer. Second is traffic control, congestion control, to see whether there is congestion or not at the network. Rate control, at what rate it's transmitting the communication. Naming and addressing, how to find the name of the network node. It should determine how to find the network node. Naming IP addresses, for example. Internetworking, how to interconnect heterogeneous network. For example, if we have, here is one network, here is another network, it should be able to connect this heterogeneous network. How it connect this heterogeneous network? It is the function of the network layer. Services and implementation. Two services are provided to transport layer. It provides two valuable services to transport layer. Transport layer is the fourth layer of the OSI reference model, which I will discuss later. Connection is service. Sender and receiver treat each transmitted message as an independent unit. In this kind of connection services, sender and receiver treat each individual message as independent unit. Connection oriented service. Sender and receiver see data as traveling on a logical connection. It see data traveling on a logical connection. Receiver receive data in the same order in which they are transmitted. For example, if we send data from here and it is destination here, it is 1, 2, 3, it is also receiving at the same sequence in which the source is transmitting this to the destination address. Sender and receiver see data as traveling on a logical connection. Receiver receive data in the same order in which they are transmitted. Connectionless service and connection oriented service can be reliable or unreliable. Now, connectionless services can be reliable or unreliable. What we mean by reliable? Delivery of all data is ensured. In reliable communication, we must ensure that all data is delivered. The receiver acknowledges data and retransmit data that was not received. For example, if it sends this 1, 2, 3 this data to destination, here at each, when it received this one, it send an acknowledgement that I received this one, then send this one, it send acknowledgement that I received data 2. In the same way, it's continuing. Unreliable. No acknowledgement or retransmission of data. In unreliable communication, we don't have acknowledgement. This is mainly due to controlled by a protocol which we call UDP, User Datagram Protocol. Reliable communication is controlled by a protocol which we call Transmission Control Protocol. I will discuss these later. Element of routing algorithm. Now the main function of the network layer is routing. So let's discuss the routing algorithm. Generally, there are three criteria to see routing algorithm. We must have to see three criteria to see routing algorithm. Which routing algorithm we must use? First is optimization criteria. Number of hops. Number of hops means cost. For example, if we have these network or nodes, here we have source, here we have destination. So how to transfer data from source to destination, either through this way or through this way and through this way. Number of hops, because each hops it's incur cost. Delay, throughput, how much delay it occur, throughput. Decision time, 1 per session, 1 per packet datagram. Decision place, each node destination routing, control node centralized routing, sending node source routing. Decision place, we have got 3 places. For example, each node distributed routing, central node, centralized node. For example, if we sending data from here to this one, this will be centralized or central node. Sending it, source routing, here is the sending node, and here each node, this one will be distributed node. Routing algorithm, we have many types of routing algorithm. Distance vector and link state. Distance vector, we have 3 main routing algorithm. It's depend on the distance. Routing information protocol, RIP, we have got RIP version 1 and RIP version 2. RIP version 2 is more advanced than RIP version 1. Gateway to gateway protocol, GGP, exterior gateway protocol, EGP. Link state, intermediate system, IS, open short is first, OSPF, which was proposed by Dijkstra, it's also called Dijkstra algorithm. Network layer protocol, what protocol are operating at network layer, third layer of the OSI reference model. So there are 2 main protocol, internet protocol IP, internet packet exchange protocol IPX, but mainly we have got IP. Main network devices, which network devices are operated at network layer, layer 3 layer at OSI reference model. So router, the router main function is routing. What is the function of the router? The function of the router is to route. Now let's define routing. Routing is the process of determining where to send data packets that are distinct for address outside the local network. For example, if we have local area network, we don't need routing. But if we are sending data from, for example, from this one network to this one network, we need router. For example, this is local area network, we don't need here, but if we send from this network to this network, we need a device which we call router. Router gather and maintain routing information to enable the transmission and receipt of these data packets. Routing information take the form of entries in the routing table. Router maintain one table which we call routing table, with one entry for each identified route. The router can use a routing protocol to create and maintain the routing table dynamically so that network change can be accommodated whenever they occur. It can be dynamical or static, but if the network is very large, dynamic routing is suitable, but when network is very small, static is also fine. You have to statically add these routing information to the routing table. This is the diagrammatic representation of router. It is Cisco router. Next we go to the fourth layer of the OSI reference model, which we call transport layer. It is the fourth layer. The transport layer function is to ensure that message is delivered error free. What is the function? That message is delivered error free. The message should not be duplicated or lost. Message should not be duplicated or lost. If there is loss, it must be retransmitted in a reliable communication. But if it is lost, it must be retransmitted. But this can happen only at reliable communication. I told you that communication is 2 types, reliable and unreliable. Reliable use TCP protocol, unreliable use UDP protocol, user datagram protocol. Transport layer provides for transparent transfer of data for user, system and application and reliable data transfer services to the upper layer. It provides services to upper layer. Upper layer means session layer, presentation layer and application layer. Transport layer services. What is the services which is provided by transport layer? So there are many services. First of all, message segmentation. It segments the message. Segmentation or chop down. The transport layer accepts a message from the layer above session layer. It receives message from the session layer. It splits the message into smaller units and passes the smaller unit down to the network layer. It receives message from above layer. It breaks down at the transport layer and it transfer it into network layer, which is the third layer. The transport layer at the destination station reassemble the message. Now it is reassembled at the destination point. It goes like this here in this way. Message acknowledgement. Provide reliable end-to-end message delivery with acknowledgement. But this is with TCP. If we are using UDP transmission, no acknowledgement can be received. Message traffic control. It also controls traffic control until the transmitting station to back up when no message buffer are available. For example, here we have sliding window like this. Send message from sender to receiver here. Again, send acknowledgement, send message again. But if there is no buffer area here, it's a backup, slow down. Session multiplexing. It multiplexes several message stream or session onto one logical link and keep track of which message belong to which session. For example, when you see, for example, if you open browser, sometimes you have multiple session. So you have multiple communication links. It multiplexes several messages, like same way it several messages stream or session onto one logical link and keep track of which message belong to which session. It is keeping track that which message belong to which session. End-to-end layer. The transport layer and the layer above are true source to destination or end-to-end layer. We have source to destination or end-to-end layer and are not concerned with the detail of the underlying communication facility. Let me show it here. For example, transport layer, segmentation, it goes to network layer. At the destination, it reassembly. Protocol used by transport layer. There are two fundamental protocols which is used by the transport layer. We have got TCP and second is UDP. Let's discuss them one by one. TCP, Transmission Control Protocol. TCP is a transport layer protocol used by applications that require guaranteed delivery. If you require guaranteed delivery, then use TCP. TCP is a sliding window protocol that provides handling for both timeout and retransmission. Sliding window protocol. Sliding window protocol, I just give you an example. For example, here this is source, this is destination. It maintains one window. We call this one sliding window. Each endpoint is defined by an IP address and a TCP port number. Here we deliver packets, so it must have got an IP address and a TCP port number. TCP establishes a full duplex virtual connection between two endpoints. For example, here we have source, here we have destination. It provides a virtual connection between these two endpoints. The byte stream is transferred in segment. The window size determines the number of bytes of data that can be sent before an acknowledgement from the receiver is necessary. Like this, I explained here above. TCP header. The transport layer header information must include control information. For example, here we have data. Here it provides header. So what these header must contain? The transport layer header information must include control information such as start of message, that messages start from here, and end of message, end flag, to enable the transport layer on the other end to recognize message boundary, so that at the other side it recognizes that message is starting from this point and end at this point. To enable the transport layer on the receiving end to get the pieces back together in the right order before handling the receiver message up to the layer above, before it sends this message or this to the above layer, it reassembles. For that reason, it must understand that the message is start from here and end at this point, and in this way it reassembles this message and it goes to upper layer. This is the rough diagram of the TCP header. Source port, for example, we have destination port, sequence number, acknowledgement number, window, checksum, urgent points. If there is the message should be sent urgently, we have urgent pointer as well, option, padding and data. So these are the overhead. It is reliable, but these are the overhead. UDP. The user datagram protocol offers only a minimal transport service. UDP cannot guarantee data delivery. It cannot guarantee delivery. It will provide best effort, but it cannot guarantee to be datagram to be delivered reliably. UDP gives application direct access to the datagram service of the IP layer. UDP is used by applications that do not require the level of service of TCP or that wish to use communication services. Multicast or broadcast delivery not available from TCP. For example, if we have multicast or broadcast delivery, we don't need TCP protocol because it will unnecessarily overhead. Second, which cannot use TCP is voice. For example, if you are communicating through VoIP, it should use UDP, not TCP. This is the header of UDP, very small. For example, source port, destination port, length, checksum, data if any. So it is very small, no too much overhead at the UDP level. UDP header. Now this is the difference between TCP and UDP. TCP is reliable, UDP is unreliable. It is connection oriented, UDP is connectionless. In TCP we have segment tree transmission and flow control through windowing. If there is segment loss, it must be retransmitted, but here no windowing or retransmission. In UDP we don't have windowing or retransmission. If a packet is lost, it is lost. Segment sequencing. In TCP we have segment sequencing. In UDP we don't have no sequencing. In TCP acknowledgement segment, we have acknowledgement segment. For example, from source to destination, if a packet is delivered, it sends acknowledgement. But in UDP we don't have acknowledgement, no acknowledgement. Now let's continue to the fifth layer of the OSI reference model, which we call session layer. The session layer resides above the transport layer, fourth layer, and provide value added services to the underlying transport layer service. The session layer along with the presentation layer adds services to the transport layer that are likely to be used of applications. It is the thinnest layer in the OSI reference model. Thinnest layer means that we don't have too much application in the session layer. At the time, why it is the thinner layer? Because at the time of the model was formulated, it was not clear that a session layer was needed. First of all, they forecast that we don't need session layer. Session layer manages the setting up and taking down of the association between two communicating endpoints, that is called a connection. When there is connection established between source and destination, it's taking association between these 2 points. A connection is maintained while the two endpoints are communicating back and forth in a conversation or session of some duration. Some connection and session last for long enough to send a message in one direction only. For example, this is peer-to-peer protocol, fifth layer, which is session layer. It's session is established between device A and device B. Function of the session layer. What is the functionality of the session layer? Dialogue control. This layer allows two systems to start communication with each other in half duplex or full duplex communication mode. Either communication should be taking place in half duplex or full duplex. Synchronization. This layer allows a process to add checkpoints which are considered as synchronization point into stream of data. Activity management. Allow the user to delimit data into logical unit called activities. Exceptional handling. A general purpose mechanism for reporting error. If there is error, it report this error. For example, data from application layer, the topmost layer, it goes to presentation layer, then it goes to session layer. From session layer, it goes to presentation layer, and data goes to application layer in this way. Sixth layer, we goes to sixth layer of the OSI reference model, which is called presentation layer. It is the sixth layer of the OSI reference model. It is also called translator layer of the OSI model because it translates. It is also called syntax layer because it deals with syntax and semantics. That's why it's also called syntax layer. It deals with syntax and semantics of the information exchange between the two devices. It was designed for data presentation, encryption, decryption, and compression. These are the functionality which is taking place in presentation layer, which is the sixth layer of the OSI reference model. Function of the presentation layer. What functionality are provided by presentation layer in the OSI reference model? So first of all, data presentation or translation, as the name indicates, presentation layer. So data presentation or translation. Because different computers use different encoding system, it ensures that the data being sent in the format that the recipient can process and understand. For example, if we are sending data from this computer to this computer, we must ensure that the data which is transmitted from the source to the destination, it must understand the format in which the data is being sent. Data encryption. It provides this facility by which hide the information from everyone except the person who originally sent the information and intended recipient. When encrypted data arrive at destination, presentation layer decrypt the message. For example, if we sending message from this node to this node, it must be in encrypted form. Otherwise, it can be hacked or someone else can see this data. Data compression. It shrinks large amount of data into smaller pieces. It reduces the size of data. It also provides data compression. This is the diagram. Data from application layer, presentation layer goes to presentation layer. From presentation layer, it goes to session layer. From session layer, it again goes to presentation layer, and finally it goes to application layer. Protocol which is being used in presentation layer. The following protocol is being used by the presentation layer: lightweight presentation protocol (LPP), network core protocol (NCP), apple filling protocol (AFP), telnet or remote terminal access protocol. The data is sent through the plain text which is unsecure. It is a remote connection oriented protocol, telnet, but it is unsecure because it sends the data through plain text, in which a third party can take these messages and can hack this. Application layer is the last layer of the OSI reference model. It is the topmost, seventh and last layer of the OSI reference model. It enables the user to access the network. It provides user interface and support for services such as email, file transfer, access to World Wide Web, Internet. It provides services to different user applications. What is the function of the application layer? Discussed in. The following are the main functionality of the application layer. Accessing the World Wide Web. Most common application today is the access of the World Wide Web. Mail services. This application provides various email services. Remote logging. A user can log into a remote computer and access the resources of that computer, which is, for example, telnet. File transfer and access. It allows user to access file in a remote host. to retrieve file from remote computer for use. It is used FTP file transfer protocol. The following protocol is being used: remote logging or host telnet. It is less secure, as I told you. File transfer protocol, connection oriented and trivial file transfer protocol, connectionless and fast. This is connectionless and fast, but this one is connection and secure, FTP. Networking support, domain name system, for example, electronic mail transport, simple mail transfer protocol. This is simple mail transfer protocol. That's SMTP, etc. For example, application layer uses from here: SMTP, telnet, HTTP, data. This is message. Application layer, this goes to presentation layer. From presentation layer it goes data again to the user. So that was all about OSI reference model. You can easily remember the 7 layer by all people seem to need data processing. This is the shortest term. How to remember this? All people seem to need data processing. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Or you can also have in the reverse order. Please do not throw sausage pizza away, in this way if you like. This is the tips how to remember the 7 layer of the OSI reference model. That's it for today's lecture. See you in the next video.